So now we're going to look at how to find the slope of a tangent. And remember, a tangent is a line that crosses or touches a curve only once using secants. It's much easier to find the slope of secants since they touch at 2 points and we can use the slope formula. So here we have a question and we're going to graph f at x equal to 2x squared plus 1 on the interval -2 to 3. So this is our domain because it's the x. Draw the tangent at x equal to 1. Choose points on either side and use to estimate the slope at x equal to 1. Now, there are a bunch of different strategies you could use. If you recognize this as a quadratic, you can graph it. But since we're given a domain, another option is just to create a table of values, x and f at x. And remember, f at x is just another notation for our y. In between -2 and 3, I'm just going to start at -2 and go up to 3. And now I'm going to put each of these points into the formula. So 2x squared plus 1. Of course, BEDMAS means exponents come first. So -2 squared is 4, times 2 is 8, plus 1 is 9. -1 squared is 1, times 2 is 2, plus 1 is 3. 0 squared is 0, so I do 0 plus 1 to give me 1. 1 is also going to give me 3 because 1 squared is 1 times 2 plus 1 is 3. 2 will give me 9, just like -2 did. And then 3 is going to give me 19. I'm going to get a graph, but I'm going to make the graph a little bit bigger than what I would normally. So I'm going to stretch it out so that things are a little bit bigger and easier to see. When you're graphing multiple secants on a graph, if your graph is too small, it becomes very, very jumbled up and very difficult to see what's going on. So I'm going to count by ones on my y-axis so that I can maybe get up to 19. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 20. Perfect. But now on my x-axis, I'm not going to count by ones because, again, that will squish the graph and be difficult to work with. I'm going to stretch my scale out as big as I can. So I only have to get to -2. So I actually think I'm going to count by 5s. That would be -1. There's -2. So 1, 2, 3, 4, 5. There's 1, 1, 2, 3, 4, 5. There's 2. There's 3. And there's 4. So I've made the graph and I've gone a little bit beyond what the domain gave me, and now I'm going to put my points on. So -2 went with 9. No, sorry, -2 went with 9. Ignore that point. -1 went with 3. 0 went with 1. 1 went with 3. 2 went with 9. And 3 went all the way up to 19. And if I connect them up, I get hopefully a shape you recognize, a parabola or a quadratic. So now, and I'm going to label this f at x equals 2x squared plus 1. We are interested in the tangent at the point where x equals 1. So the tangent is going to be a line that is just going to skim our function at that point. But the problem is I only have 1 point, so I can't use slope formula. So they asked me to pick 3 points on either side. So on this side, I'm going to start at 2, and then I'm going to pick maybe 2.4 and maybe 2.1. So here's my point that I'm interested in, which is at 1, 3, and I've picked 3 points. So there's 1, there's 2, and there's 3. And if I draw my secants, the slopes are going to get progressively closer to that. But because I've picked those points, I can actually calculate the slope. So 2 goes with 9 because that's an actual point on our graph. This point is 1.4. I'll get the y in a second by subbing it in. And then our point after that is going to be 1.2. You don't have to be right on the dot. You could pick one a little bit closer. Now, using a calculator, I'm going to figure out the y's that go with my not so nice points, my 1.4 and my 1.2. 1.4 squared times 2 plus 1. Again, I'm going back to the original function. It's 4.92. And I'll do the same thing with 1.2. So 1.2 squared times 2 plus 1. And now I'm going to keep my calculator and I'm going to find the slope between all of these points. Not going to show a lot of work. I'm just going to do my y's, divide it by my x's. So it doesn't matter the order. I'm going to go 9 minus 3, which is 6, over 2 minus 1, which is 1. So this slope is 6. I'm going to do the same thing. 4.92 subtract 3 is 1.92. 1.4 subtract 1 is 0.4. So in my calculator, I'll do 1.92 divided by 4. 0.4. The answer didn't look right. 1.92 divided by 0.4 is 4.8. And then I'll repeat the process again for this set of points. 3.88 subtract 3 is 0.88. 1.2 subtract 1 is 0.2. I'll divide, and I get 4.4. So my first slope was 6, my next one was 4.8, and my other one is 4.4. So it looks like they might be heading towards 4, but I don't know for sure. So I'm going to repeat the process on the other side. I'm going to pick 3 points and approach 1 from this side. So I'll pick 0. I'm going to pick maybe 0.8, and then 0.9, which isn't really on my graph, has a nice point, but it's getting closer and tucked up to the point. So again, 1, 3 is always going to be one of my points because that's going to be the end point of the secant, and I'm just picking a couple more. I'll call these Q4, Q5, and Q6, getting closer. So my first point was 0 and 1. Then I picked 0.8, and then I picked 0.9. And again, using my calculator in the function, 0.8 squared times 2 plus 1 is 2.28. That does not make sense. It should be, oh no, lower than 3. It does make sense. And then 0.9 squared times 2 plus 1 is 2.62. I'm going to calculate my slopes by backwards subtracting and then dividing. So 1 minus 3 is -2. 0 minus 1 is -1. So this slope will be 2. You could subtract the other way if you wanted to avoid the negatives. You only have to be consistent. I think I'm actually going to switch and do that. So 3 minus 2.28 should be 0.72. 1 minus 0.8 should be 0.2. If I do that dividing, I get 3.6, and then I'll do it one more time. So 3 subtract 2.62 is going to be 0.38. 1 subtract 0.9 is 0.1. So that slope gives me 3.8. So as I get closer this way, my slopes go from 6 between these 2 points to 4.8 between those 2 points, and then 4.4. If I approach this way, my first secant slope would be 2, then it'd be 3.6, and then it'd be 3.8. So I'm fairly confident saying the tangent slope at x equal to 1 is 4. So the slope of this line would be approximately 4 over 1.